Hi, everyone. Wow, that's loud. Hi. So I have the distinct pleasure and honor in opening this and setting the tone for the entire rest of the user group. So I'm going to try to make this as boring as absolutely possible, such that we can be like, well, not to name any other user groups, but the other user groups. Anyway, so my name's Greg. As I mentioned, it is an absolute pleasure to be here. I founded Singularity, but I'm by no means responsible for all of this. I welcomely give the blame to a whole bunch of other people, users, collaborators, developers, contributors, and whatnot. And I see a lot of people here that I know and that I've met over the years, and a lot of people that I have yet to meet, and I'm looking forward to meeting each of you. So thank you very much for coming. First, some logistics. Anybody here use Twitter? Oh, come on, you can admit it. We're all among friends. Okay, so if you tweet, use hashtag SUG19. That way everybody can find everybody else's tweet, and feel free to follow us. God, I sound like a weird commercial. So I figured it'd be a really good opportunity to open this talk with probably my #1 question that I get asked about Singularity. Any guesses on what it is? Okay, well, it's not the #1 amongst this crowd, apparently. So the #1 question has to do with this. Okay, has anybody read this book? I'm sorry. Don't tell Ray I said that. So this is a book, and a lot of people think that since it has something to do with machine learning and artificial intelligence, that Singularity is kind of named after it, right? It's not. As a matter of fact, if I would have remembered about this book when I came up with the name of Singularity, I would have chosen something different. Again, not reflection of the book at all. And if you're not familiar with the book has to do with the growth of machines and the ability of the machines to overtake and surpass that of human capability, right? This kind of sounds a little bit sci-fi-ish, right? So, speaking of which, Singularity is near. Does anybody know what happened on or was supposed to happen on 2:14 a.m. Eastern Standard Time, August 29th, 1997? Yes! Oh, you guys are awesome. Did everybody hear that? Skynet, right? Judgment Day. So, yes, we are not named after this. That would be really bad for the project. So it did make me start thinking, though. What other relations does Singularity have to the world? So I started where everybody starts, Google. All right. So here's some interesting lists. Notice we are on there. We're second from the last. By the way, this is the metric of success for the next user group. How much higher we can climb up that ladder, right? So from now on, every day, it's your jobs to at least once a day, just type in Singularity container into Google and see what happens. Okay, well, it's a good list. It's a good starting point. But where do you go from here? All right, where do you go? Who has all the answers on the internet? Who is always right on the internet? Michael Bauer admitted that it's him. Wikipedia, right? Anybody here contributed to Wikipedia? Anybody here have your keep your hands up. Anybody here still had your comments maintained after it has gone through editorials? Just 2? Okay. Anyway, what does Wikipedia have to say about Singularity? Well, there's quite a bit, actually. Okay, there's a singularity in mathematics, singularity in geometry, right? Complex analysis, natural sciences, of course, right? Natural sciences, that's the astronomical singularity. Then there's technology. Did you guys know that Microsoft made an operating system called Singularity? Anyone know that? I didn't either, but it's on Wikipedia, so it absolutely must be true. All right, but there we are. We're actually last. That's the only one I've clicked on. You can tell it's purple. But wait, there's more. Did you guys know that there's a singularity in film and television? There's singularity in literature albums, songs. There's video games called Singularity. You know what this whole thing means? Is that the Google ranking is going to be really hard. Okay, so this definitely did not give me a really concise picture of the situation and how bad it is. So where do you go if you really need your questions answered on the internet? Right? Who's with me on this? Yeah? Any Urban Dictionary users? Okay, so what does Urban Dictionary say about singularity? It is a point in time in which theoretically technological processes accelerate exponentially such that nothing taking place following said point can be predicted. This sounds a lot like the Singularity is Near book. But that makes sense, right? Because this is the second entry in Wikipedia. So what's the first? The first must be right. Top definition. Singularity is, forgive me, I'm sorry, Taehyung's new single and the comeback for BTS, Love Yourself. I have no idea what this is saying right now. So I Googled. Okay, now, show of hands, K-pop fans. Okay, we actually got a couple. You guys have guts. There's some swag and some drinks for you. We're gonna set you guys up because, yeah, wow. Okay, so I did not know even really what K-pop was. So here, allow me to demonstrate. This is K-pop. This is actually the person singing the song Singularity. I couldn't validate it though because I don't speak Korean. And if anybody wants to validate it, let me know. But it's kind of like a boy band. Anyway. Okay, for reals now. Singularity. There's two primary aspects of what brought me to the name Singularity. So the first one, this one should be obvious, right? Center of a black hole, the point of infinite density, right? Single point contains the entire universe, contains everything in there. Well, not really universe, but you get what I'm not in astrophysics. I can get away with saying things that aren't right. By the way, I'm also a CEO, which means I used to be a technologist and a developer. Now I'm a CEO, which means I'm a salesperson, and I know how to make PowerPoints, right? So you could see I'm not saying I did good, but I'm trying. All right, so singularity, right? Infinite density, infinite mass, single point, has everything it needs, all in one point. The second inspiration. Does anybody remember a company called Linux Care? Yes, we got 1, 2, 3-ish, 4. Okay. Back in the 90s, I'm old enough to remember and actually be in the 90s. Back in the 90s, there was a whole group of companies. You guys remember VA Linux? Yeah, everybody knows VA Linux. So Linux Care was right there next to VA Linux at the time. But VA Linux is the one who IPO'd first. We were actually in a race. They IPO'd first. They won all the awards. They did awesome, right? Everybody heard of VA Linux. Very few people heard of Linux Care. But out of the people that heard of Linux Care, I can guarantee you've heard of our #1 product. It wasn't a product. We created this little rescue disk called a bootable business card. And who remembers these? Okay, we got a couple more people. I happen to have one. This is Legacy Ancient Technology. It's a CD, okay? You put it in a computer, and it reads it. This is a small CD. Anybody remember seeing CDs of this size? You know what they're called? Singles. Called singles, because they're meant to hold a music single. Now, this one's even weirder because it's cut at both edges. It's cut at both edges so you can fit it in your wallet real easy. But this kind of plays havoc with the amount of space you have to write data, doesn't it? If I flip it over, you'll see the only contiguous region is right around the center. This translates to just under 50 megabytes of space. So the first versions of these, so you can imagine, a bunch of people at Linux Care. I was not on the core development team for that, but I was one of the contributing parties to it. And we're building this rescue CD. We put mini Linux system on there. We put built everything from scratch, right? And then we go and we start showing it off to other people in the company. Now, the company had a lot of really awesome developers, very well-known people. One of them was Paul Russell. He's known as Rusty on the kernel mailing list. Anybody know of Rusty? Okay, anybody knows IP tables, IP chains, hot plug? Yeah, he wrote all those. So we're demonstrating this to him, and he goes, oh man, this is fantastic. I can't believe how awesome it is. Wait, stop. rsync isn't on it. Now, Andrew Tridgell, who wrote Samba and rsync, also worked for Linux Care. You see, you got to get rsync on there. Tridge is going to be pissed if it's not. Actually, he didn't say that, but that was the gist, right? We had to get rsync on there. So we started, trying to figure out how to. By the way, I promise this will get back to Singularity, in case anyone's curious. So we're trying to figure out how to get more space on there, because we're out of room. And, well, he says, well, why don't you just compress the file system? What are you talking about? And he goes, here, let me prototype something. Anybody hear of the compressed loopback? C loop? Yeah, he wrote it right there in front of us. It was pretty cool. And we implemented the compressed loopback file system, which later became known as SquashFS, among several other iterations. Some people are starting to see the connection here finally. Long story. So we compressed the file system on here. And in doing so, because it's now a loopback file system, you have one file that represented the entire operating system on here. Any guess on what that file was called? Singularity. So this is my background. This is my lineage. I also developed something called Warewulf. Did anybody ever hear of Warewulf? Now, who here is really old and remembers the first version of Warewulf? Does anybody remember it being on a CD? Yeah, that was my totally stupid idea. Let's maintain a bunch of clusters with CD-ROM bootable images. Because after working at Linux Care and developing this, I believed all of the world's problems could be solved with a little bootable business card. Anyway, that is where the name Singularity originally came from, those two factors, not K-pop. All right, so let's take a look at the history of time, a brief history of time, pun intended. About 2014, 2015, a bunch of users and scientists started hearing about this thing called containers. At that time, containers meant one thing, Docker. And so what they were asking for is Docker on HPC. All right, so Docker on HPC. Now, I was an HPC systems architect for a long time at Berkeley Lab, and I helped to build those systems. Now, I can tell you, when we evaluated the Docker technology, and we looked at what that means to implement, it didn't seem very compatible. But it wasn't just our findings. Other centers were finding the same thing. As a matter of fact, this became a worldwide epidemic. Everybody across the board wanted Docker for HPC, and it didn't work. We could not make it work in a secure fashion. It's not that Docker is insecure, it was built for a different usage model. So how do we move forward? Well, we've identified that Docker doesn't work. I got tired of saying no to researchers and scientists that we can't help them with this. I had an interesting background with operating systems and open source projects and whatnot. So if I did one amazingly novel thing in all of this, it was I asked what they wanted. And I took that information, and that was the first specification for what Singularity has become. So, oh, by the way, Docker not on HPC made users very sad. I created a prototype. And this prototype, what I felt, really took forth all of those requirements, everything that people needed from a container system on HPC. And I made that something tangible. And I circulated that idea. And guess what? It made people happy. So I think, hey, I'm on the right track. So I then started dedicating all of my nights and weekends and whatnot to developing a project. I still had my day job at Lawrence Berkeley Lab, and just because I came up with a neat idea doesn't mean that somebody else miraculously gets to do my job. So I started working on it in my nights and weekends, dedicating huge amounts of time consistently to this. And I get to the point where I release Singularity 1.0. Now you can imagine, after I release this, I'm all proud of this, I've been doing this for a while, users weren't totally happy. There was some uptake for sure, but there were still some complaints. People said, this is really, really good, but it's not exactly what we need. So I took that feedback and I listened. And people that have known me for a while know that I'm not scared to pivot completely when I screw up. And believe me, I screw up a lot. So I spent, again, weekends and nights, and I came up with Singularity 2. Now, the reason we changed the major version is because one of the tenets that I had is that the Singularity image, the single file that represents the container, that matches the version, the major version of Singularity. So right from the beginning, I said, as soon as I change that image format, I have to change the major version. So within like 2 months, we're now at Singularity 2.0, right? Not trying to pretend to be mature, we're not, but I had to at least listen to what I said. And I hit the major users, the major usage issues that people had, and changed the format, changed a few things. Now, all of a sudden, this made users happy again. As a matter of fact, users were so happy that this had a mass adoption across the community for quite a while. As a matter of fact, the mass adoption is still continuing. I guess that kind of makes it look like it stops in mid-2017, but it doesn't. I'm even still surprised to this day about how many people are using it. So with that, I had a really interesting opportunity, and that was to work with a startup. So bear in mind, I spent about 20 years working at Berkeley Lab, and a startup approached me, and they said, we're a very well-funded startup. I'm not going to give the numbers here, but you can look on Google if you're interested. We're a very well-funded startup, and we need a container technology that approaches the container world very similar to how Singularity does, if not identical to how Singularity does it. So we're willing to fund your development, and we're willing to fund a team for you. So of course, I'm like, wow, that's great. So I took the big jump, 20 years at Department of Energy, and left and went to startup world. Wow, culture shock. But I did that jump, and gave me the opportunity to start hiring developers, start building a team. And we continued on that, at which point we started to get enterprise interest. And this is because there's a new type of compute model that the enterprise is investigating, the enterprise is moving into. Now, we've been doing compute for 30-ish years, very similar to this, right? But now all of a sudden, enterprises, which are not traditionally doing compute, are looking at very similar types of problems that we've solved long ago. So there's a lot of enterprise interest. Now with that, our store, well-funded our store, has a set of projects. It has a direction that it's going. And being a container company is not really what it's designed to do. It's not what it's set out to do. So what do? Spin out a new company, Sylabs. All of a sudden, I go from being a techie to get thrust into a CEO position. That's another culture shock. Now, the thing I didn't mention is during this whole process, we're doing 3.0 development. And we're doing 3.0 development because I hired a bunch of people that are much smarter than me. And they looked at what we were doing and they said, you know, there's a better way to do this. Unfortunately, we're going to have to change the image format. And when we change the image format, well, we have to increase the version again. And so we did that. We invested in this and we moved forward. The resulting format, by the way, is SIF. You're going to hear a little bit more talks about that in the future, or at this meeting, I mean, but future from now. We released 3.0. Now, when we released 3.0, we also included, I wouldn't say a complete rewrite, but pretty dang close. in Go. Any trendy programmers here using Go yet? Yay. Okay. I'm a C programmer. I don't like Go. So it's not that there's anything wrong with Go. I'm just too old to learn yet another language. Because you know in a few more years there's going to be another one that everybody has to learn, right? Yeah. So we released Singularity 3.0. It's written in Go, and part of the reason we did this is so we can achieve better compliance with the tools and the ecosystem of enterprise. All right, so here we are. We built Singularity completely in a silo. Before, when we started building it, OCI did not exist. Cloud Native did not exist. All right, there was no Podman. All right, so the enterprise has gone in their own direction, and we're sitting in the HPC world with blinders, not looking at what the enterprise is doing. And that's fine, right? Because we're solving different problems. But now all of a sudden, we're converging. Not completely, but there's definitely an overlap. Right? So one of the areas that we need to get better at is bridging that gap. So that's what we did. And with Singularity 3.0, it gives us the ability to be completely OCI compliant. People here heard of OCI, Open Container Initiative? What about Kubernetes? Now, I'm assuming that most people here are from the HPC side of the house and not the enterprise house, but there may be some people from enterprise. But I'm curious, on the HPC side, you've heard of Kubernetes, right? Has management said anything to you about Kubernetes? Yes. Right? A number of years ago, did management tell you something about OpenShift too? And the cloud? Right? We have to do all these things. And we, as the engineers and the architects, have to solve these problems. So what I'm here to tell you is that we're going to help you. If you have to move in the Kubernetes direction and you're interested in new types of workflows for HPC and science, we have solutions now. So this makes people really happy. I want to take a quick jump back because Berkeley Lab, I need to give them props because they've been very fantastic and supportive when I decide I want to do another open source thing. So it started back in 2001, created Warewulf. Then I created a little Linux distribution called CentOS Linux. The idea was a community-managed RPM variant of Linux. Red Hat's response was Fedora, just saying. Does anybody remember CentOS Linux? Couple people, not many. I guarantee you recognize CentOS's child. Is that right? CentOS. CentOS came out of CentOS. That sounds really funny. All right, so we're all here at a conference kind of focused on containers, so I assume everybody knows what containers are. But I'm going to sum it up real quick. All right, whenever you're looking at a piece of hardware, whether it be virtual, whether it be physical, you have your physical hardware, or you see some hardware. On top of that, you have a Linux kernel. On top of that, you have a user space. The idea of containers is we take that user space, we encapsulate that, and then we move it to another system, and then we run it. Highest level version of containers that I think, and the shortest explanation of containers that I think I've ever given myself. Singularity does some things that are slightly unique. If you're not familiar, I assume most people here are familiar, but so I'm going to go over this just real quick. All right, we have a container image format. The new container image format allows us to do things like encapsulate OCI, encapsulate the Docker format, move it around. So we still have that compatibility, but we're encapsulating it because it gives us more functionality and it gives us more compatibility with HPC systems. Plus, we can now do things like cryptographically sign that format. We have encryption right around the corner, so you can actually encrypt it. It'll actually be in-transit encryption, and while being stored, it'll be encrypted. Runtime engine. All right, one thing that we focus highly on is POSIX compatibility. So we're not trying to circumvent POSIX compatibility, all right? We're utilizing it to our advantage, and we need to, because most of our HPC systems, users don't have root on, right? We may have 10, 100,000 users, and all of them have to be able to leverage the container system without the risk of increased privilege. So the runtime also has to be able to block privilege completely. And it has to be compatible with things like resource managers and things like MPI. So I'm not an MPI expert. I know a little bit about MPI. But when I first developed this, I realized that MPI was going to be a problem. And so I talked to some friends and some people who I know in the MPI community. I saw Ralph at some point here. There's Ralph. I invited Ralph to Berkeley Lab among several others, and we sat and hashed this out and talked. Wasn't at the same time, but we all talked. And we figured out what makes the most sense. How do we run an MPI workload through a container? And that's what we ended up with, how the standard way that we run MPI through Singularity. It's a hybrid model. It's a hybrid approach. As a matter of fact, Ralph has gone on further to develop even more, a further compatibility layer for that I think Ralph's going to be talking about later. So the runtime engine is different, and our image format is different. As a result of this, we've had massive adoption, massive growth. So we can account. Now, when I say we can account, that's because people have reached out to us as either customers, they've signed our public registry, or they've just let us know. We can account for multi-millions of container runs per day, download count of almost about a quarter million, installed on over 5 million x86 cores, 250,000 ARM now, and I believe that number is going to be increasing substantially at some point. There's a lot of interest in ARM. And we've been approached by most of the cloud providers at this point as being a solution for increasing the utilization of GPUs in their cloud. And this is because, again, one of the things I didn't talk about before, but what Singularity does is it helps to achieve compatibility with different versions of things like GPUs inside your container. So if you have one version of CUDA running inside your container, you want to run it on a host that has a different version of the kernel modules for that GPU, Singularity can help bridge that gap. So we have some initiatives now also happening on the Sylabs side. By the way, one thing I want to mention, this isn't in the slide deck, is that whenever there's an open source project and a company comes along behind it and tries to create a business model, there's been lots of opportunities where companies have really done this wrong. There's lots of examples of what not to do in the community. There's only a few examples of how to do this right. Not saying we know the proper recipe for how to do this right, but I can tell you we're doing things differently than what most people have done. One is we are not holding the open source code hostage at all. It is always going to be open source, and all of our development in Sylabs, everything that we are putting into the project is open source. We're always putting that 100% directly into the community. That goes into the master branch. When we develop something like a product like Singularity Pro, we're taking from that GitHub, and we're pulling it back out. So even though we've pushed everything to it, now we're going to take snapshots of that. And that's what we commercially support. You can almost think about it like the Fedora and Red Hat Enterprise Linux model. The other way is to add value to the open source project without holding it hostage by doing other things. Like one of these is a key store. So I've mentioned kind of tangentially that our container formats can be signed. Right? This is PGP signatures, so it has public-private key pairs. You sign it with a private key. You distribute your public key so people can validate. This is a distribution platform for doing public key validation. This means you can do things like Singularity Sign. It automatically will ask you if you want to push those keys up into the Sylabs key store. Once you've done that, you can take that container, run it, bring it anywhere else, and not only guarantee immutability, you also have a guarantee of accountability. You know who signed it. So if you trust that person, you can trust that container. So we offer a service to help distribute those keys. We also offer a service for sharing your containers, storing your containers, archiving your containers. One of the primary things about Singularity is the absolute ability for reproducibility, right? People in the pharma space have been really interested in this. Did you guys know that there's an FDA mandate that whenever code is being used for medical treatment or diagnosis, You have to make sure that that is archived for 5 to 10 years, and you can guarantee that that stack can always be reproduced. Do you guys know that there's something very similar in aerospace, oil and gas, financials? So our container library offers the ability to very easily go back to a signed version and replicate that entire workflow. Now, people that are familiar with Singularity, has building your containers been a problem? Yes? Right, because it requires root. All right, so this is a build service, and you'll be able to build either on our cloud resources, and also all this stuff would also be able to be run on-prem, so if you're interested. Additionally, we've been moving forward with things like OCI. I believe, Ian, if you can give me the thumbs up or down if I get this right, our membership in Cloud Native is today. Today, the release announcement is going out from Cloud Native. Oh, it went out 10 minutes ago? Oh, fantastic. And we're also moving forward now with the Linux Foundation AI project. So we're going to further be helping on that front and be part of that. Kubernetes, I already talked a little bit about Kubernetes. This gives us the ability to kind of work with new types of workflows. So AI, in terms of the AI and ML workflows, they have a little bit of a different paradigm than we're typically used to in HPC. It's close, but not exactly. The top part is really close, right? You have the build and train. It's very computationally intensive, but when you go to do those inference or you want to run those models, most of the time, not always, but a lot of the time, you're actually running on a different resource. Right? You're going to push those models out to the edge. You're going to run them somewhere else. Singularity is really uniquely fitted to help with the mobility of this model. I like to still pretend I'm an engineer, so I like to put up complicated slides every now and then. This demonstrates a workflow where you basically are using a very traditional-like HPC system to build your models, distribute that trained model with Singularity, and then you can pull that model in via a Kubernetes instance that can be doing a different type of compute analysis. This gives us the ability to do things like real-time AI, real-time analytics, data streaming. Has anyone here been faced with too much data coming into your system? Right, so we've been approached by a couple labs that have detectors that have massive amounts of data coming off these detectors. And they don't want to persist it. They want a real-time analysis of that data. Right? You can't do that with a traditional HPC batch mode, right? Because then you'd have to persist all that to disk, then break it up into pieces, and then submit these little bits to the scheduler. It's not real-time. It's not even close. Right? You need to start doing orchestration of compute-based services to do this. So we've had a lot of interest in that. And that's one of the main areas where Kubernetes is coming into the discussions. What about Kubernetes and Slurm together? So we've been thinking about this as well. What if we were to meta-schedule Slurm instances or HPC resources together using Kubernetes? All right? So this is something that we've been investigating in, and I'm going to be releasing something shortly. Prototypes for this and proof of concepts are already all done. So this is where the technology is going. All right, so if you've got users with a lot of different accounts on multiple systems, or you as a resource provider have multiple systems, and you want to bridge those together for users, this is a way of doing that. Apple. So I just recently gave a talk at an oil and gas conference, and I was absolutely blown away with the number of non-Mac systems, and specifically Windows systems. Now here, Mac definitely is winning. I don't know if you guys can tell, but I can tell. And I'll bet, I just have a gut feeling that some of the non-Mac systems are running Linux. Guys, yes, yes? Okay. I won't ask people to do a show of hands how many people are running Windows because I don't want to embarrass anyone. But how would you like native support on the Mac of Singularity? So all of the containers that are already created, all those Linux containers, you can run natively now on the Mac. So, and you can interface with your Mac, things like your Mac file system directly. And it takes a little bit longer to start up, as you can see up there in the example. When you type in Singularity shell and you point it at a container image that sits on your disk, it takes about a second versus thousands of seconds to run. So it takes a little bit longer to start up. But once you're in it, it works just fine. This gives you the ability, obviously, not only to run Linux on your Mac without having a hypervisor and all of the other overhead, but it also gives you the ability to do things like run TensorFlow directly. Make use of all of the containers that are up in the container library or all the containers that you're using on your HPC resource, or develop containers for your HPC resource on your Mac. This means we can run things like Kubernetes. You can run all the Docker containers. You can run SPAC. Anybody here using SPAC? We've got a talk on SPAC coming up. Horovod. Anything. It all runs natively. This is going to be released at this user group. So we're in alpha version of this. And everybody here, if you wish, will be able to download this and use this. There are some pieces in it which cannot be open sourced, but we are making sure everything is freely available. Maybe we'll be able to open source it at some point. All right, so I want to take a moment and thank everybody, you guys for coming. I want to thank San Diego Supercomputing Center for hosting us. So collaborators, contributors, developers, our sponsors, and call out a few names as well. Aaron, Susan, Ian, Sean, thank you guys. You guys have done a fantastic job setting this up. And thanks.